All right, so today I'm going to come in and talk about the elimination method. Okay, so the elimination method for solving a system of equations is real simple. You're going to add these two equations together to make one variable go away. That's all it is. Now, unfortunately, there is no, if I add these, I'll get 4x. If I add these, I'll get 6y. I need one of these to go away. So what I have to do is I have to dream up of a way, and it's usually pretty simple. It's usually some kind of integer, to make these two equal or opposite, or to make these two equal or opposite. So here's what I'm going to do. I'm going to multiply this bottom equation by -3. Okay? So if I multiply that by -3, I get positive 3x up here, negative 3x down here. The x's will go away. Let's see what we get. So I get 3x plus 2y equals 16. So just take this first equation, copy it. Second equation, I'm going to multiply everything by -3. So I get negative 3x, and then 4 times -3 is negative 12y, and 22 times -3 is negative 66. Now I'm going to add these two equations together. Okay, just going to add them together. And if I do that, what do we get? Well, 3x minus 3x is 0. They go away. This will give me negative 10y, and this will give me negative 50, right? So 16 minus 66 is negative 50. Cool. Well, that's really cool because if I divide both sides by -10, I get y equals 5. Now, the other method we can use is called substitution. You have to know substitution because we always use it, even if we use elimination. So I'm going to substitute this value into one of these equations. Which one doesn't matter. Pick one. I'm going to pick the bottom one because the bottom one is simpler to me. You can pick the top one, you'll get the same answer. So I'm going to take this bottom equation here, and I'm going to say x plus 4y equals 22. Now, I know y is 5, so I'm going to go ahead and put y equals 5 into that. That gives me x plus 20 equals 22. And if I subtract 20 from both sides, I get x equals 2. So there's my answer. The only other thing I can add to this is to go ahead and write my answer in point form, because if you're in a math class, that's how we expect you to write it. 2, 5. X first, y second. Okay? Let's try a different one. Okay? So I'm going to get rid of x this time, and I say, okay, well, I got 5 and 2. Well, if I multiply that by 2, I get 4. That doesn't work. If I multiply that by 3, I get 6. That doesn't work. How about over here? I'll try this one. Multiply that one by 2, I get -6. That doesn't work. Okay. I multiply that by 3, I get -9. Oh, that doesn't work. So this one, you actually have to come up with a number to multiply both equations by. And pretty much, guys, this is like finding a common denominator. Okay? If you can find a common denominator with a fraction, you can solve this. So if I look at 2 and 5, the common denominator between 2 and 5 is 10. Make both of those 10, make one of them negative, voila. The common denominator between 3 and 8 is 24. Make both of these 24, voila. Okay? So if you can find a common denominator, you can do the elimination method. Now, I'm going to make this easy on myself. I'm going to get rid of y. And the reason is because one of them is already negative, one of them is already positive. It makes my life a little simpler. So I'm going to multiply this top equation by 8, and I'm going to multiply this bottom equation by 3. And let's see what we get. All right, so 2 times 8 will be 16x minus 24y, and then 26 times 8 is going to be 208. 208. Should have brought my calculator for that one. 208. Cool. And then here we're going to multiply 5 by 3. Oh, that doesn't. Oh yeah, 5 by 3. So that gives me 15x. We're going to multiply 8 by 3, which gives me 24y. Right? So those two are equal but opposite. They'll go away. That's just a smudge on the paper. And then 34 times 3 is going to be 102. 102. Cool. All right, so what happens here? Boom, boom. Add these together, those cancel out. All right, 15 and 16 makes 31x. And then 208 and 102 makes 310. And if I divide both sides by 31, I get x equals 10. Cool. X equals 10. Now what? Now substitute that answer into one of these equations and solve. Which one? Doesn't matter. I'm going to use the top one this time. Since I used the bottom one last time, I'm going to use the top one this time. Okay? So I get 2 times 10 minus 3y equals 26. All right, well, 2 times 10 is 20. So you get 20 minus 3y equals 26. If I subtract 20 from both sides, I get negative 3y is equal to 6. Okay? Last step's to divide both sides by negative 3, and we end up with y equals negative 2. Okay? Final step, if you're in a math class, is to put this as a point. Always x first, y second. So this will be 10, comma, negative 2. Okay? 10, comma, negative 2. Voila. Okay? Now, most of our systems of equations do come to nice, pretty answers. 2, comma, 5, 10, comma, negative 2, 2, comma, 4, 5, comma, 1. But every now and then we come to a couple of odd things. So I want to show you those as well. So here we go. Look at number 3 here. Okay, so we got x plus 2y equals 8 and y equals negative 1/2 x plus 4. Okay, so you can solve these by substitution or elimination. I'm going to solve this by substitution because I have y equals blah, blah, blah. Okay, if you haven't watched it, I have a video on substitution. Make sure you watch that too because you need to know both methods. Okay, so I've got x plus 2y equals 8. So take that equation, write it down. And everywhere I have y, I'm going to put negative 1/2 x plus 4. Negative 1/2 x plus 4. Cool. So I'm going to distribute, and I'm going to get, that's going to be plus negative x, and then that's going to be plus 8 equals 8. Something like that. Okay. Well, x plus negative x is 0. This is all going to go away. Okay, what am I left with? I'm left with 8 equals 8, which is a true statement. Okay? Fun. I'm going to come back to that. Okay? Your variables go away, you're left with a true statement. Okay? Actually, I'll go ahead and tell you what it means, and then I'm going to come back and show you how you have to state your answer. Okay? So a true statement. What this means is you have an infinite number of solutions. Okay? Whenever you get a true statement, you get an infinite number of solutions. Cool. All right. Now, let's take this guy over here, number 4. Same thing. We're going to try and get rid of these. I'm going to use elimination this time. I'm going to multiply this top equation by negative 2. Okay? So let's see what that gets me. That's going to get me negative 6x minus 2y equals negative 14. The bottom equation I'm just going to copy. 6x plus 2y equals 18. And when I add these together with the elimination method, the x's go away, the y's go away. So everything on this left-hand side is 0. And then negative 14 plus 18 is 4. Well, 0 doesn't equal 4. This is a false statement. A false statement. So whenever you get a false statement with no variables, this is no solution. Or some folks will say it's the empty set. Okay, so your system, the answer to your system is the empty set or no solution. Cool. Okay. Now, I'm going to come back to number 3 I told you there are infinite solutions. If you write that, it is going to be wrong. It is not an incorrect answer, but it's going to be wrong. I'm going to show you why, okay? If you play with these two, what you will see is they're actually the same line, okay? This line and this line are on top of each other, okay? So, I'm going to give you a scenario, okay? You have this line, and I'm going to draw it twice. Okay, so X and Y, okay? For scenario 1, you say infinite, come on, pen, don't hang on the dresser, solutions, infinite solutions, okay? If you say infinite solutions, that's the answer you give. You're saying the answers are everywhere. Everywhere in this coordinate plane. Well, the answers aren't everywhere in the coordinate plane. That's not right. Again, if you inspect this system, what you'll see is that these two equations are the same line. So you actually have two lines laying on top of each other, okay? You actually have, scroll up here so you guys can see this, you have an infinite number of solutions. And this is the important part, on this line. Okay? You have an infinite number of solutions, but they're only on this line. So you have a solution here, and a solution here, and a solution here, and a solution here, and a solution here, right? Cool. Okay? So we have to say this. And I'm going to go back to my equation. I'm going to show you how to say that. Okay? So I have two ways of saying this. I'll write them both out. Okay? Two ways of writing infinite solutions on this line. Okay? One way is to put y as the variable, and then put the equation here. Okay, what this is telling the reader is if you pick a y value, plug it in here, this will give you the x value. Okay? No, I wrote that wrong. Let me do that again. That one's incorrect. Try that again. Sorry. If we pick an x value, -1/2 x plus 4. They have to have the same variable. Okay? It helps if you actually do it right for the students, doesn't it? Right? So what this is saying is pick an x value, 1, 2, 5, 10, doesn't matter. Plug it in here to get the y value. Okay, where did that come from? Y equals, okay? Now, I told you I was going to show you the other one, okay? The other one has to look like this. It has to have a y here, and then an equation with y in it here, okay? Which is going to be your x, okay? So I'm going to go back up to my original equation. I'm going to solve this for x. So I'm just going to move that guy over. So x equals -2y plus 8. Okay? That would be your two answers for this problem. Okay? And what they'll say to you is make x the arbitrary value or make y the arbitrary value. Okay? So that's what they're saying. They either want they want an answer with all x's, or they want an answer with all y's. The way to remember this, if y is the arbitrary value, you put a y here, and this is going to be whatever equation you have for x. So it's going to be x equals blah, blah, blah in terms of y. If x is your arbitrary value, you're going to put an x here, and then you're going to put an equation for y. This means pick an x value. This equation will give you the y value. This means pick the y value. This equation will give you the x value. Okay? So give that a try. Hopefully that helps you guys. This would be the correct answer, not this. Because if you say infinite solutions, you're saying that it's all over the graph, like so, and not only on this line, like so. All right? So if you have any questions, leave them in the comments. If you have an idea or you need help with something, shoot me a message. Hope it helps you.